Welcome to MasterCode. I'm glad you're here and I'm glad you made it to episode 2. Today we're talking about one of the most foundational decisions you'll ever make as a hacker or security professional. We're talking about your operating system. Your OS is your battlefield. It's where everything happens. Your tools, your terminals, your payloads, your word lists, all of it lives inside your operating system. And if you pick the wrong one, you'll be fighting your own machine instead of fighting your targets. So today we're going to cut through the noise and get you set up properly. We're covering the 6 most popular hacking operating systems. We're going to compare them honestly, talk about their strengths and their weaknesses, and by the end of this episode you'll know exactly which one matches your skill level and your goals. We're also going to do a full installation walkthrough, set up a proper virtual machine lab, and cover everything from package management to disk hardening. This is not theory. This is the exact setup that professionals use every single day in real penetration testing engagements. Whether you're on a high-end workstation or a budget laptop, by the end of this video you'll have a functioning, professional hacking lab. Let's build it. Before we touch any tools, we need to talk about ethics. Not because it's a box to check, but because this stuff genuinely matters and it could keep you out of prison. The cardinal rule is simple. You need written permission before testing any system that is not yours. That means explicit, documented, written authorization from the person or organization that owns that system. Verbal permission means nothing legally. An email saying, "Sure, go ahead" is better but still risky. You want a proper signed scope document. Second rule, use isolated environments. Everything we do in this series happens in virtual machines and CTF platforms designed for learning. We never point tools at real targets without authorization. Third, know the laws in your country. In the United States, the Computer Fraud and Abuse Act makes unauthorized access a federal crime. In the UK it's the Computer Misuse Act. In most countries the penalties include prison time, not just fines. And fourth, responsible disclosure. If during your authorized testing you find a real vulnerability in a real system, report it properly. Contact the company's security team, use their bug bounty program if they have one, or use a disclosure platform. The hacker community earns respect through responsible behavior. And the professionals who get hired by top companies are the ones who operated with integrity from day one. We clear? Good. Now let's build your lab. There are more operating systems out there than most beginners realize, and they're not all equal for security work. Let me walk you through the 6 that actually matter. First, Kali Linux. This is the gold standard. It's built by Offensive Security, the same organization that runs the OSCP certification. 600+ tools come pre-installed and ready to use. It gets security-specific updates faster than anything else out there. Most tutorials, courses, and certifications assume you're running Kali. This is the one most of you should start with. Second, Parrot OS. This is the lightweight alternative. If your machine has limited RAM or an older CPU, Parrot runs better than Kali while still including all the major tools. It also has a stronger privacy focus with built-in Tor routing options. Third, BlackArch. This is for power users. It's built on Arch Linux and has 2,800 tools in its repository. If you've ever thought, Kali doesn't have what I need, BlackArch almost certainly does. Fourth, Ubuntu and Debian. These are standard Linux distros where you build your own toolkit manually. Great for learning. Fifth, Windows with WSL2. This combines a familiar Windows desktop with a Linux terminal. Viable for developers who need both environments. And sixth, Tails OS. This is the anonymity-first option. Boots from USB, routes everything through Tor, and leaves absolutely zero trace on the host machine. Different tools for different jobs. Know them all. Let me tell you why Kali Linux is the overwhelming choice of professional penetration testers. It's not just because it's popular. It's because every single decision in its design was made for this specific job. The tool selection is not random. Offensive Security, the company that builds Kali, is the same company that designed the OSCP course and exam. When they pick which tools go into Kali, they're picking based on what actually works in real engagements against real targets. That curation matters enormously. The rolling release model means you're not waiting 6 months for a stable version with updated tools. Kali updates continuously. When a new version of map drops, you get it. When a new Metasploit module is released, it shows up in your next update. You stay current without doing anything extra. The community is massive. Every tool in Kali has tutorials, forum posts, GitHub issues, and YouTube videos explaining how to use it. When you get stuck at 2 in the morning during a CTF, someone has already answered your question somewhere online. The kernel customizations matter too. Kali includes kernel patches that are specifically useful for wireless hacking. Things like support for certain Wi-Fi adapter chipsets that are needed for monitor mode and packet injection. You don't get that out of a standard Ubuntu install. And the documentation from Offensive Security is genuinely world-class. Kali is a professional-grade tool. Treat it like one. Let's get specific and compare the 3 most popular security-focused operating systems side by side so you can make an informed choice based on your actual situation. Kali Linux is the professional's choice. 600 tools pre-installed. Debian-based SO apt package management works exactly as expected. Excellent hardware support, especially for wireless adapters. The OSCP community almost exclusively uses Kali, so if you're heading toward certifications, this is your path. The downside is resource usage. Kali is heavier than Parrot and needs at least 20 GB of disk space for a comfortable installation. Parrot OS is the beginner-friendly option. It runs on as little as 2 GB of RAM, which means it works on older or budget hardware. It's also Debian-based, so the learning transfer between Parrot and Kali is seamless. The privacy tools are a genuine differentiator. Built-in Tor support, a non-serve for routing traffic anonymously, and a clean interface make Parrot a solid starting point. The tool selection is slightly smaller than Kali but covers everything you need at the beginner and intermediate level. BlackArch is the power user system. 2,800 tools in the repository. Arch-based, which means you get bleeding-edge package versions. Maximum customization at the cost of a much steeper learning curve. There's no graphical installer. You configure everything yourself. The payoff is a system that is perfectly tuned to exactly what you need. My recommendation: start with Kali. Add BlackArch tools via its repository overlay when you need them. You get the best of both worlds. Alright, let's actually install Kali Linux. I'm going to walk you through 5 steps and give you exactly what you need to know at each stage. Step 1. Download the ISO from kali.org. Go to the Get Kali section and choose the installer edition, not the live edition. The installer gives you a permanent installation. After downloading, verify the SHA-256 checksum against what the website lists. This sounds boring, but it's important. A corrupted image causes mysterious failures halfway through installation and wastes hours of your time. Step 2. Create a bootable USB drive. On Linux you use the dd command. On Windows use Balena Etcher, which is free and straightforward. Write the ISO to a USB drive that's at least 8 GB in size. Step 3. Boot from your USB. Restart your machine and open the BIOS or UEFI settings. On most systems you hold Delete or F2 during startup. Select your USB drive as the boot device. You may need to disable secure boot on Windows machines. Step 4. Run the guided installer. Select your language, time zone, and keyboard layout. When you reach partitioning, beginners should choose guided partitioning with LVM and full disk encryption. This encrypts your entire installation automatically. Step 5. First boot setup. The moment Kali boots, open a terminal and run your updates. Your first update after a fresh install often involves hundreds of packages. Let it run completely before you start any tool configuration or testing work. You've installed Kali and you're looking at a fresh desktop for the first time. Exciting moment. But before you start playing with tools, you need to do proper system initialization. This is what separates professionals from impatient beginners. First thing, run your update. The command is sudo apt update followed by sudo apt upgrade with the yes flag. This downloads and installs all available updates. On a fresh install this could be 300 to 500 packages. Let it finish. Do not interrupt it. After your base update, decide how many tools you actually want. Kali has different meta packages. The base install includes around 100 tools. The Kali Linux Everything package installs the complete toolset. This downloads several gigabytes of additional tools. If you have the disk space and want everything available, install it now. If you prefer a leaner install, you can always add individual tools later as you need them. After tools, add anything that's missing from your workflow. Web security researchers typically add GoBuster, FUF, and FerexBuster, which are modern web fuzzers not always in the base install. Network pentesters add MassScan and RustScan for faster scanning than map alone. Then verify your key tools are working. Check map, check Metasploit, check Python 3. If something's broken, better to know now before you need it in the middle of a test. This initialization takes maybe 30 minutes. Do it right once. 600 tools sounds overwhelming. And honestly, it is at first. But here's how to think about it. The tools are organized into categories and you only need a handful of tools from each category to be effective. Information gathering is where every engagement starts. Map for port scanning. Multigo for relationship mapping. Reconning for OSINT. The Harvester for email and subdomain collection. These 4 tools handle most of your reconnaissance phase. Vulnerability analysis is your next stop. OpenVAS for automated network vulnerability scanning. Nikto for web server scanning. SQLmap for SQL injection testing. These tools don't exploit anything. They find what might be exploitable. Exploitation is where Metasploit dominates. It's one of the most powerful frameworks ever built. Searchsploit gives you offline access to the ExploitDB database. Beef handles browser exploitation for social engineering demos. Password attacks is a whole discipline on its own. Hashcat uses your GPU to crack hashes at extraordinary speed. John the Ripper handles a wider variety of hash types. Hydra and Medusa do online brute force against login pages. Wireless Attack Center on the Aircracking suite, which we covered in depth in the Wi-Fi Masterclass episode. And web application testing lives inside Burp Suite, which is the industry standard tool for web penetration testing. You don't need to master all of these at once. Pick one category, go deep, then move to the next. That's how professionals actually build skill. Building a proper lab environment inside virtual machines is one of the most important investments you can make in your learning. Let's set it up properly. Step 1. Install VirtualBox. It's free, open source, and runs on Windows, Mac OS, and Linux. Download it from virtualbox.org or install it via your package manager. Step 2. instead of installing Kali from scratch inside VirtualBox, use the preconfigured OVA image from kali.org. Go to Get Kali and look for virtual machines. Download the VirtualBox OVA. Then in VirtualBox go to File and Import Appliance. This gives you a fully configured Kali VM in about 10 minutes with no installation required. Step 3. Configure networking carefully. Set the network adapter to host-only mode. This creates an isolated private network between your VMs. Your attacker machine and victim machine can communicate with each other, but neither one has access to your actual internet connection or your real local network. This is critical for safety and legality. Step 4. Install guest editions. This enables clipboard sharing between your host and VM, automatic display resizing, and shared folder access. Step 5. Take your first snapshot right now, before you install anything else. Call it Clean Install. This is your baseline. Everything else gets built on top of it. If you ever completely destroy your configuration, one click restores you to this clean state in under a minute. This is one of the most debated topics in the beginner security community. Should you dual boot Kali alongside your main OS, or should you run it inside a virtual machine? Let me give you both sides honestly so you can make the right decision for your situation. Dual booting gives you native hardware access. This matters most for wireless hacking because some Wi-Fi adapter chipsets only work properly when the OS has direct hardware control. Performance is also better. There's no virtualization overhead. The downside is that dual booting is riskier to set up, especially on Windows machines where grub bootloader issues can leave you unable to boot either OS. You also can't take snapshots of a dual-booted system, and switching between OSes requires a full reboot every time. Virtual machines are the clear recommendation for most beginners. Your host OS remains untouched. You can snapshot before every risky operation. You can run multiple VMs at the same time. You can clone VMs instantly for parallel testing. The performance difference is minimal for most tools. The only real limitation is USB device pass-through. If you want to use an external Wi-Fi adapter for wireless testing in a VM, you need to configure USB pass-through in VirtualBox, which is a few extra steps but definitely doable. My recommendation is start with a VM. Once you're comfortable with the tools and genuinely need native hardware access for wireless work, consider adding a dual boot. There's no shame in using VMs, professionals use them constantly. Virtual machine guest editions are one of those things that beginners often skip and then spend months being frustrated by a poor VM experience. Let me show you how to install them properly and what they actually unlock. Guest editions give you 3 major quality of life improvements. First, clipboard sharing. Without them, you can't copy text from your host machine and paste it into your VM. This makes moving commands, IPs, and payloads between environments incredibly painful. Second, automatic display scaling. Without guest editions, your VM runs at a fixed low resolution and doesn't resize when you change the window size. With them, your desktop scales automatically and looks sharp. Third, shared folder access. You can designate a folder on your host machine that the VM can read and write. Great for transferring tools, word lists, and output files. Installing in Kali is straightforward. Run sudo apt install VirtualBox guest x11 then reboot. After reboot, enable the service and everything works automatically. For shared folders specifically, you need to add your user to the box group using add user with your username and box. Then log out and log back in. After that your shared folder appears at the path shown in VirtualBox settings. This whole process takes about 5 minutes. Do it on every Kali VM you create. The workflow improvement is significant and immediate. Parrot Security OS deserves more attention than it typically gets in hacking tutorials. Most content creators default to Kali and that's fine, but Parrot has genuine advantages that make it the better choice for certain situations. The headline feature is hardware efficiency. Parrot runs comfortably on 2 GB of RAM. This makes it the practical choice for older laptops, budget hardware, and low-powered machines like older ThinkPads or budget Dell systems. If you're trying to learn on limited hardware, Parrot is your answer. The Security Edition includes all the major tools. Metasploit works perfectly. Burp Suite runs great. Aircracking is there. Wireshark, SQLmap, Hydra, John the Ripper, all present and accounted for. The tool selection covers 90% of what you need for beginner and intermediate work without the heavier resource footprint of a full Kali installation. Parrot also comes in 2 other useful editions. The Home Edition is Parrot without security tools, designed as a daily-use privacy-focused desktop. The Privacy Edition includes a non-surf, which is a system-wide traffic anonymizer that routes everything through Tor. For research work where you need anonymity, this is a powerful feature. One thing that really stands out is the development environment integration. Parrot includes Python, Ruby, Go, Git, and Docker out of the box. If you're doing security research that involves writing your own tools or working with existing ones from GitHub, Parrot has everything ready without additional setup. Give it a try. You might be surprised. BlackArch Linux is the system for people who've outgrown Kali and want access to tools that don't exist anywhere else. Let me tell you what makes it special and who it's actually for. The first thing that gets everyone's attention is the tool count. 2,800 plus tools in the repository. To put that in perspective, Kali has around 600 pre-installed tools. BlackArch has 2,800 available to install. Categories include things you've never heard of like binary exploitation tools, anti-forensic tools, hardware hacking utilities, and specialized wireless attack tools that go far beyond the standard aircracking suite. BlackArch is built on Arch Linux, which brings both power and responsibility. The Arch Package Manager, Pacman, gives you access to the absolute bleeding edge of package versions. When a new tool releases, it typically shows up in the BlackArch repository within days rather than weeks. The Arch user repository adds thousands more software options on top of that. The Slim ISO option is genuinely useful. You don't have to download 15 gigabytes of tools you'll never use. Download the minimal ISO, install a base system, then add exactly the categories you need. This produces a focused, efficient system rather than a bloated one. Here's the important point though, BlackArch rewards patience and punishes rushing. The learning curve is real. Arch-based systems expect you to read the documentation, understand what you're doing, and fix problems yourself. The payoff is a system you understand deeply and that does exactly what you need. That deep understanding makes you a better hacker overall. Package management is one of those foundational Linux skills that every hacker needs to have completely internalized. Let me walk you through it for Kali and its alternatives. In Kali and Parrot, you use apt, which is the advanced package tool. The most important commands are these. apt update refreshes your local list of available packages from the repositories. This doesn't install anything. It just tells your system what's available. Always run this before anything else. apt upgrade then downloads and installs newer versions of your currently installed packages. apt install followed by a package name installs new software. You can install multiple packages in one command by listing them all separated by spaces. apt search lets you find packages by name or description. This is useful when you know what type of tool you need but not the exact package name. And dpkg with the list flag shows you all installed packages, which you can pipe through grep to check if something specific is installed. For BlackArch users, you're using Pacman. The syntax is different but the concept is identical. Sudo pacman with the capital S uppercase Y uppercase U flag does the full system upgrade. Lowercase s searches the repository. Capital S installs a package. BlackArch also provides a helper called Blackman that simplifies installing groups of tools by category. Install the entire mobile category with one command instead of listing dozens of individual packages. The habit to build, update at the start of every session. Outdated tools miss current vulnerabilities and sometimes simply don't work correctly against modern targets. Your desktop environment affects your productivity more than most people realize. A poorly configured workspace makes you slower and more prone to mistakes during time-sensitive tests. Here's how to set it up right. The first decision is your window manager or desktop environment. Kali defaults to XFCE, which is lightweight and functional. GNOME looks better but uses significantly more RAM. i3 is a tiling window manager that gives you maximum screen real estate for terminals with zero mouse usage required. i3 takes a few hours to learn, but after that your workflow becomes significantly faster. Tilix or Terminator are excellent terminal emulators that support splitting your terminal into multiple panes. This lets you run map in one pane, watch a packet capture in another, and edit a file in a third, all on one screen without alt-tabbing. Color scheme matters for long sessions. The default Kali terminal colors work but aren't optimized for readability. Tokyo Night, Dracula, and Grovebox are popular choices that reduce eye strain. Import them from GitHub in a few minutes. Custom shell aliases are one of the biggest productivity multipliers. Instead of typing map space dash s capital V space dash s capital C space dash P space dash dash open, you type something like ns, which expands to the full command. Set this up in your bashirk or zshrc file. Do the same for your most common Metasploit, GoBuster, and SQLmap invocations. This customization takes an hour. Do it once and benefit every session going forward. Let me give you a straightforward comparison of the three main desktop environments you'll encounter in hacking OSes so you can make an informed choice rather than just using whatever the default is. XFCE is the Kali default, and for good reason. It's lightweight, starts fast, and uses around 500 megabytes of RAM at idle. It's not the prettiest environment, but it's functional and customizable. For most beginners this is the right starting point. Just learn it and move on to actual hacking tools rather than spending a week configuring your desktop. GNOME is the modern choice. It has a clean, polished interface that feels more like a contemporary operating system. The extension ecosystem is excellent and you can customize it significantly. The cost is resource usage. GNOME needs at least 2 GB of RAM to run comfortably and can feel slow on machines with less than that. If you have hardware to spare and prefer a nicer interface, GNOME is a solid choice. i3 is the productivity maximizer. It's a tiling window manager rather than a full desktop environment. Every window automatically tiles to fill available space. There's no overlapping windows, no alt-tab hunting for terminals. Everything is keyboard-driven. The configuration lives in a text file you edit manually. The learning curve is real. You'll spend a few hours reading documentation and configuring it. After that, your workflow is dramatically faster and more efficient than any traditional desktop environment. My personal take: use XFCE until you know Kali well, then experiment with i3 when you want to optimize your workflow. Desktop environment choice doesn't make you a better hacker, but it does affect how efficiently you work. Your attack machine contains sensitive information. Client engagement details, your custom tool configurations, word lists you've built over years of work, possibly even report drafts with vulnerability details. You need to protect it, not just the targets you test. The first thing you must do after every fresh Kali install is change the default password. The Kali default credentials are Kali/Kali. They're in every tutorial ever written and in every attacker's dictionary. The moment your attack machine has a weak password, you're a target yourself. Use a long, unique passphrase. Next, configure your firewall. Install of with apt and enable it immediately. By default, block all incoming connections. You can add exceptions for specific ports as you need them. Your attack machine should not be listening on open ports unless you explicitly need that for a test. Disk encryption needs to happen at install time, ideally, using LUKS, which is the Linux Unified Key Setup. If your machine is stolen with an unencrypted disk, everything on it is readable. Client data, your notes, your tool's configuration. LUKS encrypts the entire disk and requires your passphrase at boot. Set it up during installation. Always. VPN usage before testing is non-negotiable for professional work. Your real IP address should never appear in target logs. Route all test traffic through a commercial VPN or a self-hosted one. And keep your attack machine separate from your personal machine. Don't use your hacking VM for personal browsing or accounts. Separation protects both your privacy and your clients. Network configuration is a daily skill for hackers. You need to be comfortable reading interface information, configuring network modes, and routing your traffic correctly before any test session begins. The IP address show command is your first stop. It shows all network interfaces, their IP addresses, and their current state. You'll use this constantly to verify that you're on the right network, that your VPN is working, or that your wireless adapter is in the right mode. IP route show displays your routing table. This tells you which interface handles traffic to which destinations and what your default gateway is. When traffic is going somewhere unexpected, the routing table tells you why. Network Manager handles most modern network configuration in Kali. NCLI device status shows you all interfaces and their connection state. NCLI Con show lists saved connection profiles. When you're doing wireless work, you'll frequently switch between managed mode for normal Wi-Fi and monitor mode for capturing packets. The IP link set command handles this along with the IW tool for wireless specific operations. For anonymity, proxy chains is incredibly useful. It routes your tool's traffic through a chain of proxy servers. Run proxy chains followed by any command and that tool's connections go through your configured proxy chain. Verify this is working correctly using curl to an IP lookup service before running any tools. And remember to use tcdump or Wireshark to capture traffic when you need to analyze what your tools are actually sending. Understanding network traffic at this level separates competent testers from exceptional ones. Snapshots are your insurance policy and your time machine combined. If you're not using them systematically, you're taking unnecessary risks with your work. Let me explain exactly how to use them effectively. Your first snapshot should be taken immediately after your initial system update and configuration, before you install any specialized tools. Call it clean base or something clearly descriptive. This is your nuclear option. If you ever completely break your system, you restore to this and start fresh. It takes seconds to restore versus hours to reinstall and reconfigure. Before each new engagement or test session, take a named snapshot with the date and what you're about to do. If the engagement goes sideways, if your tools start behaving unexpectedly, if you install something that breaks a dependency, you roll back to where you were and continue without losing hours of work. The OV export feature is for long-term backup. Once a month or once a quarter, export your configured VM as an OVA file to external storage. If your host machine dies, you restore the OVA to a new VirtualBox installation and you're running again within minutes rather than days. VM cloning is underused by beginners. Before installing any experimental tool, clone your VM first. Do the experiment in the clone. If it works, replicate the changes in your main VM. If it breaks everything, delete the clone and move on. Your main VM stays clean. The documentation habit ties everything together. Keep a text file inside your VM that lists what you've installed and configured. When you come back to an old snapshot 6 months later, you'll know exactly what state it represents and what work you still need to do. Let me talk about hardware because it matters and because a lot of beginners overspend or underspend based on bad information. The minimum viable setup for running Kali in a VM alongside a target VM is 8 GB of RAM with a 4-core CPU and a 100 GB SSD. This works. It's tight but it works. You'll be able to run tools, complete CTFs, and learn everything in this series. If you can invest in 16 GB of RAM, do it. The difference between 8 and 16 GB when running multiple VMs simultaneously is dramatic. With 16 you can comfortably have your Kali VM, a Windows Target VM, and a Metasploitable VM running at the same time. That's a realistic lab. 32 GB is the power user configuration. You can run 5 or more VMs, replicate complex network topologies, and do serious red team lab simulations. For most learners this is overkill but nice to grow into. Beyond RAM, the piece of hardware that unlocks wireless security work is a dedicated external Wi-Fi adapter. The Alpha AWS036ACH is the most commonly recommended adapter in the security community. It supports monitor mode and packet injection which are required for Wi-Fi penetration testing. Your laptop's built-in adapter almost certainly does not support these modes. The rubber ducky and similar USB devices are for physical penetration testing. If that interests you, it's a fun area to explore but not necessary for most learners starting out. Budget recommendation: a used or refurbished ThinkPad with 16 GB of RAM, great Linux hardware support, and a durable build. Add an SSD if it doesn't have one. Excellent value for learning. Let me describe the complete professional lab setup that you're working toward and show you how everything fits together as one coherent system. Your host machine runs Windows or Ubuntu as your daily driver operating system. This is where your browser, productivity apps, and personal accounts live. VirtualBox is installed on the host but your personal life stays completely separated from your hacking activities. This separation protects your privacy and your clients. Your primary attacker VM is Kali Linux fully configured with your tools, aliases, word lists, and session notes. This VM is on a host-only network adapter so it communicates only with other VMs, never with the real internet during tests. You take snapshots before every session and export OVAs monthly. Your victim VM is a deliberately vulnerable target. Metasploitable 3 from Rapid7 is designed specifically for practice. VulnHub has hundreds of downloadable vulnerable VMs at every difficulty level. DVWA, the damn vulnerable web application, runs inside a VM and gives you a full web application testing environment. These are all legal and designed for exactly this purpose. The two VMs sit on the same host-only network. Kali can attack Metasploitable. Metasploitable cannot reach your real network. Nothing goes outside. This is a completely closed, isolated environment. As you advance, you'll add more VMs to this lab. A Windows Server target for Active Directory practice. A web server for advanced web application testing. A router VM for network analysis. The lab grows with your skills. This 3VM foundation is how you start. Build on it. You now have everything you need to build a professional hacking lab. Operating system selection, installation, virtual machine setup, package management, desktop configuration, hardening, network setup, snapshot strategy, and hardware recommendations. All of it. This isn't theory. Every single thing we covered today is directly applicable to your real work, whether that's CTF competitions, learning environments, or eventually professional penetration testing engagements. Here's what I want you to do right now. Download Kali Linux if you haven't already. Import the VirtualBox OVA. Take your first snapshot. Label it, Clean Install. Then come back for episode 3 where we go deep into Linux mastery for hackers. We're talking about the command line tools, file system navigation, scripting fundamentals, and all the Linux knowledge that separates someone who uses Kali from someone who actually understands it. Because the tool is only as powerful as the person using it. And the person using it needs to understand the OS underneath. Episode 3 drops next. Subscribe so you don't miss it. And if this episode helped you, the algorithm rewards a like. It costs you nothing and it helps this channel reach more people who are serious about learning security. See you in episode 3.